We will now walk through some recommendations to ensure that your servers have a basic level of security protection when it comes to configuring and providing access. My first and foremost recommendation for servers to prevent unauthorized access is to deploy servers as immutable components. What does this mean? This means that once an instance is launched from a machine image, it does not undergo any changes. Any changes that need to be done in order to install and run application code will be done by building a pre-configured image. Let's look at how this image would be built. Immutable instances are launched from virtual machine images that are preloaded with everything that is required to run an application. Starting with the base operating system image, we can use automation to apply security patching, hardening, and any other custom operating system configuration. This hardened image can be consumed by application teams to customize with their application code and produce an image ready for deployment. Scanning the image for security vulnerabilities is also a good idea prior to deployment. Once the image is deployed as an instance into the environment, it does not get updated. When it's time to update the application or make any other changes to the instance, a new image is created and deployed in place of the previous version. With this process in place, no individuals need to log into an instance once it's been deployed. This is a huge step in the right direction for protecting instances from security breaches and unauthorized access. If immutable instances are not an option in your environment, the next best thing is to use a configuration management tool to enforce hardening and configuration policies. In this situation, an instance's system configuration is maintained in a version control repository. Changes are made by users updating the code, and there is no need to log into the system. In the event where a user deployed an instance with insecure configuration, let's say for example allowing access using personal keys or passwords, the configuration management tool would override this by applying the correct configuration. Some popular tools in this regard are Ansible, Chef, and Puppet. But if console access is still needed, configuration management tools can be used to apply other secure access methods such as Privileged Access Management or AWS Systems Manager. Taking this a step further, the use of a Privileged Access Management or PAM tool can provide additional benefits such as time-based or temporary access to elevated privileges, granular privilege management, session recording and audit trails, password and secrets management, and multi-factor authentication. There are many products and solutions on the market that provide this type of access management support. A few brands include Thycotic, Centrify, and CyberArk. AWS provides similar functionality with Systems Manager Session Manager tool. You'll have the opportunity to see this in action in the next exercise. Finally, in addition to choosing a method for providing access, it's critical to observe a few additional best practices. Keep instances up to date and patched. Enforce hardening that encompasses security best practices around OS hardening. Add monitoring for vulnerabilities to ensure that either OS or application vulnerabilities are addressed as soon as possible. Implement monitoring and alerting for suspicious events using tools such as intrusion detection systems or security information and event management tools. To wrap things up, it's quite obvious that providing and managing secure access to instances is quite challenging and come with its own set of risks. From a security perspective, it is advised to move away from this type of model and use pre-built images with the use of a configuration management tool in order to limit or eliminate the need for access.